Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about periodic trends, and I'm going to be talking about different periodic trends in different videos coming up. So in this video I'm going to focus in on the atomic size or atomic radius trend that we see in the periodic table. And one of the things I'm going to keep saying in all my videos is, in order to understand the trends, you have to go back to what is happening with regard to the attractive forces between the nucleus and the electrons, and you have to kind of think of what's going on quantum mechanically in the atom. So we got to go back to the effective nuclear charge and things like that. So we're always thinking about Coulomb's law, right? So Coulomb's law is where you have the attractive forces of different charged particles. Here we have repulsion, and we have attraction going on between the nucleus and the electrons, and repulsion between the electrons. And so let's get into this. Um, so we want to talk about atomic size. Let's go back to what's going on between the nucleus and the electrons. And let's go back to effective nuclear charge. So as we are going across the periodic table, in any period, you'll notice that the nucleus is getting bigger. So every single time we go over one atom in the table, we're adding a proton to the nucleus. And according to Coulomb's law, remember, the larger the charge is, the stronger the attractive force that is going to be there. Okay, so that means that as you go across, the amount of attractive force is increasing in the nucleus, and we can see that in the effective nuclear charge that we calculated in an earlier video. So the red numbers here represent the effective nuclear charge felt by the electrons. So the outer electrons are feeling a greater effective nuclear charge as you go across this way. So going from left to right, the electrons are feeling a greater charge or force on them. Well, what's going to happen to the electrons that are feeling the greater force? They're going to be attracted more strongly, and they're going to be pulled in closer to the nucleus because of that larger attractive force that they're feeling. And so that's going to make the atom smaller, right? So if we can remember that the effective nuclear charge is increasing going this way, then it makes sense that the atomic radius or the size of the atom would decrease going across left to right. And again, that's because the electrons are being pulled more strongly towards the nucleus, and so therefore they're going to go in a little bit more. And so you could see the pictures that I drew, that the size of the atom is gradually getting smaller from left to right. Okay, so that is a periodic trend going across the periodic table this way. And you could see that here too. So again, going across here, you can see that the effective nuclear charge is increasing from a +1 to +2 to +3, 4, 5, 6, and so on. And so because these electrons are feeling a greater attractive force, because you got more protons in the nucleus, and yet the shielding doesn't change, right? So the shielding electrons here are always 2. So we have 2 shielding electrons here, 2 shielding electrons here, 2, 2, 2. So the amount of shielding doesn't really change as you go across, but the number of protons is changing. You're putting a proton in the nucleus each time, and so you can see that the effective nuclear charge gets larger. Same thing here. So you can see here that the number of core electrons is 10. Same thing here. Number of core electrons is 10, 10, 10. So the amount of shielding from the core electrons doesn't change. So, but we are adding protons each time we go over to the next group. And so that's increasing the effective nuclear charge. And again, you increase the effective nuclear charge, you're increasing the attractive force of the nucleus on the electrons, and so that's going to pull in, excuse me, that's going to pull in those electrons closer, going to make the atom smaller. And so, again, as we're going across left to right on the periodic table, the atom gets smaller. What about going down a group? What happens to the effective nuclear charge? Well, we saw that the effective nuclear charge doesn't really change. Well, why is that? Because for here you're adding protons, so you're adding protons to the nucleus, but you're also adding a new layer of core electrons, and that new layer of core electrons will counteract the number of protons you've added, so that the effective nuclear charge stays the same. So here the effective nuclear charge stays the same. So here we're not looking at the size of the charges as far as the attractive force goes, because the size of the charges is going to be the same. We got +1, so +1 for each of these. So the number of core electrons is going to cancel out the number of protons you've added, so that really the effective charge stays at a +1. So when we're looking at the size of the atom, notice what we're adding as we go down each period, right? So here, remember the period number corresponds to the number of energy levels you have. The group number corresponds to the number of valence electrons. So you'll notice here in group 1, we have 1 valence electron, 1 valence electron, 1 valence electron. For group 2, we have 2 valence electrons, 2 valence electrons. Group 3, we have 3 valence electrons, 3 valence electrons. So the group number tells you the number of valence electrons on that outermost shell. But what does the period number tell you? Notice that all of the atoms in period 2 have what? They have 2 energy levels, 2 shells, right? Energy level number 1, number 2. Notice period 3, they have how many energy levels? 1, 2, 3. Period 4, 1, 2, 3, 4. So the period number tells you the number of shells or energy levels that an atom will have that's in that period. So what is causing the atom to get bigger? You're adding shells. So as you go down a group, because you're adding energy levels, and as you add energy levels, the atom gets bigger, those electrons get farther from the nucleus. So what's the trend going down a group? The atom gets bigger. As you go across, the atom gets smaller. So down here I have my rectangle. This is going to represent my periodic table. So when I put in the trend, so if we're talking about atomic size, it's going to or decrease going this way. So if you go this way, left to right, atomic size or atomic radius decreases. And so as you go up, right, so as you go up a group, atomic radius also decreases, or atomic size decreases, right? So as you're going up the group, atomic radius decreases. As you go this way, atomic radius decreases. And so the overall trend in the periodic table is decreasing this way. So atomic radius decreases and decreases. And that, ladies and gentlemen, is the trend of atomic size in the periodic table based on what we understand going on with the effective nuclear charge and what's going on with the number of shells being added as we go down a group. I hope this was helpful. I hope you enjoyed this video. I hope you learned something from it. If you like my videos, please smash that like button. Please hit that notification bell. Subscribe to my channel so you can be notified of other videos I put out. If you like my videos, you probably want more, right? So put a comment in the comment section. Let me know what you think and if you have any questions. Thanks for joining me and have a great day.